100k ohm, 100k ohm, 100k ohm. In P controller, I gave gain is equal to 3, and I assume that I reduce 30k ohm and RI is 10k ohm. In integrator, I will use the capacitor with have a values of 100 microfarads and 10 kilo ohm. The last one is called summing amplifier. The summing amplifier. The function of this summing amplifier is simply just to combine two atoms between P and I and send to output. So it is called summing amplifier. Simply just combine two effects. Output from the P controller I will call V out 1, and output from I controller I will call V out 2. And of course, because we don't need any gain at the summing amplifier, so I can use the same value of the resistor for all resistor in the circuit. Then I can define the gain is equal 1. So we just combine the effects of P controller and also I controller, you will get one output. And this is the output from the controller that you will set to the right and control your actuator to move in the percent that you need from 0% to 100%. Input of this circuit is reset point and VPV. VPV come from the sensor in the automation process, and reset point is something that the operator will define. You can define it by using the adjustment of the voltage, or you can define it as a digital input is also depend on the structure that you have already built for your circuit. Today we will continue that how can understand that what should be the response of the output of the controller when we assume that we get the value from the sensor by chance. Look like this graph. So this graph is something that you make a historical data. All the graph here is in historical data. Historical data is means it will keep the data in each second for analysis. In the SCADA system, also you have to keep everything in the historical data. And in the market, it's also called, this is the logging data, or data logger. Data logger is the device that can keep historical data. Okay, we continue this. By this, with this circuit on the right side, you have to evaluate the output signal from other amplifier. We out 1, we out 2, and we out from controller. Again, what is this? This is something that you measure from sensor by time. PV will connect to this input. What is this error amplifier? Error amplifier is V error. In this position, output from the differential amplifier. Where is the V out 1? V out 1 is output from P controller. Where is V out 2? V out 2 is the output from integrator. Where is the V out? The hour here is something that we chose at the output of controller. That is the combined effect between T and I. Okay, let's do one after the other. We start from the first one. The first graph is called the error. We can start from here. V error is equal to, what is the formula here? Because V error is the difference between V set point and VPV, so V error can be written as V set point minus VPV. Well, it is very easy, but you have to do it by chance. And before we start to do anything, it is more clever to make a line between each connections. I will try to make a small line. Now I try to make the connections between time and each graph. First we start to do with the error. Error is equal to set point minus PV. So let's see the first interval here between 0 to the second interval time. So what is this? 5. We have a set point at 5 volt. It is the PV values. So what should be the answer here? So V error is equal to the set point minus VPV. Set point is equal 5, VPV is equal 5. 5 minus 5 is equal to 0. So you will get something like 0 here. 0. Okay, the next step. You have 5 set point minus PV. Set point is equal to 5 volt. PV is equal to 4 here. So 5 minus 4 is equal to plus 1. So in this position you have plus 1. And what is the next? The next is also 5. 5 minus 5 is equal to 0. The next step is 5 minus 6. It is equal to 6. 5 minus 6 is equal to minus 1. So you will have a minus 1 here. So minus 1 is down here. It is minus 1. Then the last step, you have 5 minus 5, and it is equal to 0. And you have to continue to make the connection line. You will get something like this or we will.
แล้วก็หยิบบอกตัวให้หน่อย
Do
หยิ
you
บใส่ที่หัว
understand?
ชาร์จก็ได้นะ
The next step we have to evaluate. We outform learning. First, we have to understand the output equations of this circuit. So once we know that it is inverting amplifier, so you simply just write down the output equations. So V out 1 should be equal to gain multiplied with input. Input of this circuit is the other, and what is gain? Gain is RF divided by RE. So we have KP whole multiplied with V. So what is KP? KP is gain is equal to RF divided by RE, but it is in negative voltage because it is an inverting amplifier. Then you will get something like minus 30k ohm over 10k ohm, so you have 3 minus 3 multiplied with V. Now we try to evaluate Vout. Vout 1 is equal to minus 3 multiplied with V earlier. So you have to use minus 3 times V earlier here. So V earlier in the first section here is 0. So you have a 0 multiplied with minus 3. Then output will equal to V. Output will equal to 0. And then the next interval here, you have the order of plus 1. So plus 1 times minus 3 then you will have minus 3. Minus 3. So minus 3 is here. The next step is here. This interval you have 0. So you have the error of 0 volt times minus 3. You will get another 0 here. And these intervals, 1 second interval here, you have minus 1 of the error. So substitute this one, minus 1 times minus 3, you will have plus 3. Plus 3 is over here. Yeah, plus 3. The last section, you have this 0 volt. 0 volt times minus 3, you have 0 volt again. Then simply just write the connection line. You will get the graph look like this at the output of P controller. Do you understand? Who has questions? You can ask. May I repeat again? The first graph comes from the calculations of these equations. V error is the output of the differential amplifier, which is equal to V set point minus VPV. And V set point is defined here as 5 volt. VPV is according to the graph. And you have the first interval as 5 minus 5 is equal to 0. Then the next sections here, you will have a set point of 5 volt, 5 volt minus 4. Then you have plus 1. In these sections, you have 5 volt minus 5 volt, you get 0. So in this section, you can have 5 volt minus 6. Then you get minus 1. And the last section here, you have 5 minus 5 again, then you have a 0 voltage. Then the second graph is the response of P controller at the output. So V output or output from P controller is equal to gain multiplied with V error at the input. Input of the inverting amplifier is the error, then we have to make a multiplications of gain. And gain in P controller is called KP. KP is equal to RF over RIn. You have 30 kilo ohm over 10 k ohm. Then you have a gain of 3. Minus 3 multiplied with the error. That is the response of VL1. So the first section, you simply just take this V error of 0 to make multiplications to the minus 3, you have a 0. Then the second interval here, you will have 1 times minus 3, you have minus 3. So this interval, you have a 0 again, multiply with minus 3, you have 0. The result of this interval is minus 1. Minus 1 times minus 3, then you have plus 3. And the last section here you have a 0 times minus 3, you have 0. Until this step, if you have any questions, you can ask. Okay, everyone can do it. Then I will go to the next graph. The next graph is the response and the output of I controller. Where is I controller? I controller is here. I controller. That is the output that we want to know. But before we can do this, we have to know the equations of the output first. The equations of the output is like the last time, it also depends on the rate of change at the input. So I could derive dV out to by dt is equal to one factor, but this factor has to make a negative voltage because the input of the circuit is at the inverting in, so you have a minus here. Minus Ki multiplied with V. So we use Ki values, you choose the rate of change at the output of the controller. Okay, we continue. Now is the question is, what is Ki? Like we learned last time, Ki is equal to 1 over Ri multiplied with Ci. With multiplication to the input we learned. Then you have minus 1 over Ri, where is Ri? Ri in this case is 10 kilo ohm and Ci is 100 microfarads. So you have to make the multiplications between 10 kilo ohm times 100 microfarad and make up multiply with 3 over. If you use the calculator to make calculations, you will get the first constant of 1. So 1 over 10 kilo ohm times 100 microfarad will equal to 1. Then the last equation must be minus 1 multiplied with 11. What is the unit? Volt per second. Why is volt per second? Because now the equation is trying to determine this rate of change, the relationship between V out and times. So the unit will be volt per second. Last time I tell you that when you make the integrations, you always has V plus V0 at the end of the equations. What is the meaning of V0 at the end of the equations? It is mean the voltage at the beginning. So I have to define the beginning voltage upon the capacitor that we use in the integrator circuit. And now I will define it as 0 volt. Let's see step. The next step is you have to make the calculations. In this calculation, you need the information of VL. So what should be VL2? VL2 is equal to minus VL. Minus VL. What is the VL here? The first interval is 0. So now you will get something like, in this interval you will get something like 0 volt per second. What is the meaning of 0 volt per second? 0 volt per second, it doesn't mean that you will get 0, but it means that it will have no change. So if the starting point is 1 volt, you will still have 1 volt. If the starting point is 0 volt, you will have 0 volt. That is the meaning of 0 volt per second. 0 volt per second is mean no change. No voltage change anymore. It also depends on the previous voltage. So now the previous voltage is 0. Then you will get something like 0. We continue to the next step. The next step is minus VL. The next step VL is equal to 1. So you will get VL2 is equal to minus 1. Minus 1 volt per second. In this interval, you will get something like minus 1 volt per second. What is the meaning of minus 1 volt per second? It means that in the next second, the voltage will reduce for 1 volt. The next second after the second before, then you will get the voltage reading for 1 volt. So it means that now if the voltage is at 0 volt, in the next second it will go to minus 1. In the next second it will go to minus 2. The next second it will go to minus 3. And the next second will go to minus 4. That is the meaning. So minus 4 will be around here.